Hey everybody, so this is Friday's lesson, April the 17th. So what we're going to look at today is something called common logs, natural logs, and change of base. Alright, basically what we're going to do is this section is going to help us to be able to use our calculators to find approximate solutions. And I know that doesn't sound too big and bad, and it really isn't, but there's a few things we have to have laid out to learn how to use our calculators. Now before I get started on the section, I do want to show you that you can use any calculator you have. The ones you have, if you bought one of the simple scientific ones for class, those work. Or if you're using a fancier one like a TI 83 or 84 or 89 or Inspire, those work. Or you could just use the calculator on your computer. So if you didn't know how to open that, make sure you kind of figure it out and play with it. If you're on Windows, you can just press the Windows button and go to Calculator. Now I do want to show you something. A lot of these are default set to standard, which doesn't have the logarithm button. But if you click the three little bars over here, you can change it to scientific, and it has logarithm button. Or you could even go really fancy if you wanted to feel cool and have programmer ones, but that's all. That's kind of, just click on scientific. It'll be better. So the scientific one has logarithmic buttons. Okay, so I'll teach you about those later. I'll bring that back up throughout the lesson. So let's kind of see why we'd want to know this. Okay, so for example, consider this. Log base 2 of 8 equals something. Can I figure out log base 2 of x? And the answer is, yeah, I can. I have it typed beneath, and you can get this handout on the email and posted in Blackboard. But we know we could rewrite this as 2 to the x equals 8. Please, please, please make sure you remember how to rewrite logarithms as exponential equations, functions. And then we could kind of say, oh wait, 2 to something equals 8. Oh yeah, 2 to the third. So we know that this is 2 to the third, so that x must be 3. So we could solve it. That's not why we need a calculator for. This is not bad to reason through. Why we need a calculator for is, for one, this is just what I just did, because you can rewrite 2 to the third equals 8. What about a problem like this, log base 2 of 11? If you were to try to rewrite that, you'd say, okay, so 2 to the x equals 11. X must be, That's not going to be pretty, is it? Because you're going to say, well, 2 to the third is 8. 2 to the fourth is 16. It's somewhere between 3 and 4, but it's going to be some nasty decimal. And I don't know that off the top of my head, right? No one should know that. Actually, to give you a little bit of history, I have one of these books in my office. If we weren't quarantined, you can come see it. Back before calculators were as powerful as they are, they published entire books of tables to have logarithmic values in them. And you could just have a book of logarithms. And literally, you would have to look up the ones that were not perfect and look up all these values. That was the only way to do it, where supercomputers had done them and printed them for people, because their supercomputers were about as powerful as our calculators now. Now our calculators can handle this, but let me show you how it's not as straightforward as you may think. So some nasty decimal, that's all I've said. So this is where we need to use our calculators. I'm not going to do this one yet. I'll come back to this example at the end of the lesson once we know more about using our calculators. So log base 2 of 11. What's it equal to? Some decimal between 3 and 4. We'll figure that out, okay? So first, let's look at our calculators. Notice that they have a log button and a natural or an ln button. LOG and LN. Those are all they have on them. Well, what do these buttons mean? Well, if we just do log, there's no base there. It means base 10, okay? And if you click the LN button, that's actually a log with this natural base. It's Euler's number. It's a special number, kind of like pi. It has a lot of significance in other levels of math. It's a really fancy number. It's really awesome. So these are the two logarithms that every calculator that has logs are going to have, is log base 10, the common log, and log base e, the natural log. Okay, and that's what I laid out next is, oh look, log 5, log base 10 of 5 is called the common log. So if I just, most people only clarify if they need to that this is the common log. You don't really need to know the names of them. But we can actually use our calculator to figure this out. Okay. Now, depending on your calculator, some calculators are going to have you press the log button first and then the 5. But this one, if you're using a calculator just like this one, you'll probably have to press the 5 button first and then the log. And you see it says, oh, that's log of 5. It's backwards. It'll be like that on a whole lot of those tiny scientific calculators. Play with your calculator until you figure out how to use it. Okay, so if you do the log of 5, this is what you get is 0.69897 blah blah blah. See how long that decimal is? These are gonna be really nasty decimals. We'll end up rounding. Most often we'll round to the 4th decimal place. Just read the instructions whenever I ask you to do something. Okay, so that's how you do a log base 10. It's really that easy. You can just press the number, then press log. That's really awesome. Okay, and this is just where I tell you that you may have to press 5 first, then log, or the other way around. It just depends on your calculator. Play with whatever calculator you intend to use to make sure you understand how to do it. Now, what's the other one? Oh, yeah, so we can write the answer there. What was it? 0.69897. I think I can just copy this. Let me see. Copy, paste. There we go. Okay, and if we wanted to round it, let's say, okay, that's the approximate symbol, 0.69. Ooh, so if we want to round the 4th decimal place, the 7 means this rounds up to 10, so 0, and that 1 adds there, so 6990. Don't worry about the rounding too much. That's not what I'm here to teach. Worry about getting the 0.6989-ish. Okay. So now the other one. If I do the ln, ln means the natural log. That just means log based e. So this is called the natural log. Like I said, we're not too worried about the name. And the same thing applies. So let me clear this out. Clear. Clear the history too. I don't like seeing the history. If I can make it not viewable. I don't know. Some of them you'll press the ln first, then the input. This calculator you have to press the 5 first, then the ln, and it will tell you what that is. And it should be a different number than the base 10. So let me get a few decimal places of this and copy and paste it in. Paste. Whoops, it's way up there. 1.609. So there we go. That's the natural log of 5. So these are really easy to find. If I ask you a base 10, a common log, or if I ask you a natural log, an ln, those are really easy to find. What's more complicated is, what if I ask you to do something that's not base 10 or base e? What if I ask you to do something that's not common or not natural? Remember our first example? It was log base 2 of 11. That's base 2. That's not 10 or e. That's not the common or the natural log. How do I do one like this? And most calculators don't have somewhere for me to put this in. Now, if you're using a fancier like TI-84 might have it. I had to go look at mine. Or an Inspire might have it. But you don't really need it. I'll show you why. It's actually really easy to fix. We use something called a change of bases. We change the base. So right now this is base 2. I can change this. I can change a logarithm to any base that my little heart desires. Well, what base am I going to want to change this to? Either 10 or e, because 10, my calculator can do base 10. So we're going to want to change all these bases to base 10. Well, how do you do this? With this very simple formula. So whatever the base is and whatever the input is, you just separate it out into a fraction of logs. That's kind of tiny. Let me write it larger. On top, whatever number you were trying to do, divide about on the bottom, the logarithm of whatever the base was originally. And I just went ahead and made the formula do base 10. So you literally can use any base you want, but we're trying to do this in our calculator. So what base are we going to want? Base 10s. So the common logs. And it's easy to remember which one goes up and which one goes down, because this is already written as a subscript down low, right? The base is already written down low. So it goes on the bottom of the fraction. The input will go on the top of the fraction. So we can just use this. So here is our first example that we were worried about trying to do. Log base 2 of 11. Well, I can change this to common log of 11 divided by the common log of 2. Once again, notice the base goes on the bottom and the input went on the top, and they're both logarithms with the same base, and this can be any base that I want, but I'm going to want something that can be input into my calculator. Now, how am I going to type this in my calculator? Very carefully, okay? We don't want to find one then the other. We would like to do this all at the same time. So log 11 over log of 2. So I'm going to very carefully use a parenthesis. Remember, I have to do the number first, so 11 log, close parenthesis, divided by, do another parenthesis, 2 log, close parenthesis. Now here's what's really annoying if you're using these scientific calculators and it gives you a value. I haven't hit equal yet. This is actually the value of log of 2. This is not the whole thing yet. So please be careful and do hit the equal sign. And there we go. Log of 11 divided by log of 2 is this 3.45943. Control copy. Let me paste it. So there we go. I rounded it because I couldn't go on forever. I chopped it off. But that's how you will find these logs that are not of base 10 or not of base e, is I can just rewrite them with the change of base formula so that they have base 10. Or if you wanted to, watch this. I could have done these instead of common logs. The formula says I could switch it to any log I wanted to. So I could have even done natural logs divided by, whoops, it's going to want me to go back in and, okay, let's see if it gives me an error here. Let me clear this and try this again. Parenthesis 11 natural log, close parenthesis, divided by parenthesis 2 natural log. This is going to give me the same answer. I don't know how many decimal places I carried it, but look, no matter which one I use, no matter what the base is, it's the same answer. So we just change it to a base that our calculator has. So we can try like one more if you want to, but that's log base 5 of 3. Can I do this? Yeah. Use the change of base formula to write it as a log of 3 divided by the log of 5, knowing that I would like this to be base 10, so I'm going to write it as a common log. And then I will use my calculator to do log of 3 over log of 5. Clear everything out. Let's clear the history because it makes it look too busy. 3 log, I forgot my parentheses, but it'd actually be okay. Over, what was it, 5? 5 log, hit enter. Make sure you hit enter. And this is it right here. So there we go. So that's all we have for you. So go try the worksheet. Okay. The worksheet has a few problems where you're doing a few of these logs just like this. Okay. This is the second to last section or lesson in this section. So this is the second to last lecture of material that we have. So what we'll do on Monday is do the last section. On Wednesday, you will take test 5. It'll work just like test 4. I'll have it set up in Blackboard and it will open up. I'll send an email with more information. And then Friday and Monday are the last 2 days of class. And what we'll do is we'll review for the final through the videos. Okay? So make sure you watch the videos for those last 2 days because our finals week is the week after that. Well, the week of that Monday. And I'll do the test the same way through Blackboard. Okay? Well, y'all have an awesome day, an awesome weekend. I hope y'all are all well.